Hello everyone, so today we are going through Leetcode daily challenge, delete operation for two strings. So in this question, we are given with two strings and these two strings are like this, that we are required to return. Basically in these, we are given with these two strings, and in these two strings, we are required to return the minimum number of steps so that both the words which are there, they could be same. And in one step, you can delete exactly one character in either string. So basically, one step means one operation would be there and moving ahead with equalizing both of them. So, and next thing is that time constraints which are given, not only time constraint but constraints which are given to us is the length of both of them could be at max 500. So even if we go ahead with n square solution, then that could also work, because then it will go to 10 to 4, so it will work. And next thing is that word 1 and word 2 consist of only lower English letters. So yeah, we don't need to keep a check over the uppercase letters and so on. So then again, it becomes somehow easy for us to go ahead with the solution. So let me first explain you about this question, how it is. So we would be given with two words, right? And in these two words, here C and eat is given. We are required to return 2. How this 2 comes up? What we are required to do is, in this C and eat, first we need to check that which one we need to delete. So if we delete S from C, then it becomes EA, right? And if we add T to this EA, then it becomes eat, right? So if we delete S from C and if we delete T from eat, then our word would be EA, right? So here we are required to delete two characters, one from the C and other from the eat. So basically these two characters need to be deleted, and after that only it will become equal, right? So what we are now we need to think in other direction, that if we combine the length, that is 3 of C and 3 of eat, which will become 6, and then if we subtract the combined common characters of both of these strings, that is EA and EA, right? Then there is 2 and 2, 4, then 6 minus 4 would be 2, right? And then our answer, we get that answer from this particular formula, right? So this 3 is the combined length, and this 2 is the common chars in both, and 2 is that one which is uncommon char, which are required to add or subtract, which is not a concern that it need to be subtracted or added, but we need uncommon chars as our answer. So this is what is the requirement of the question. So after getting through these examples, only just this one example, by this behavior of this question, it reduces the question to finding LCS, that is longest common subsequence, but the final answer is given by this, that is combined length minus LCS into 2, because 2 is the LCS and we are multiplying by 2 to get our final answer. So that's why this is the formula which is required. Basically, this is the only thing which is the modification being done in this question, else this question is of LCS only. So before moving ahead, let's start from the brute force approach of doing LCS, that is the recursive approach which we are required to follow for going ahead with an LCS solution. So here is the recursive tree which would be required for doing this particular question. So the thing is that when we encounter C and eat, right? So we need to check for the last char of both of them. If both of them are equal, then it's alright. We need to subtract both of them, A and T. But here they are not equal, right? So in that context, we are having two options. Either we'll subtract A. Here I have subtracted A from C. So EAT is as it is, or we'll subtract T from the EAT, and here that's why I have taken EA, and C is as it is. So these are the two options when there is no match of characters, right? So that we could check out that any possibility is there in these characters when we move ahead of this particular portion of the string. So now let us now check for this portion. Then I'll take that E and T, both of them are not equal. Then again I'll subtract E from the S, or I'll subtract T from the E. So like this becomes the next substrings. Then after that I'll delete if from here. So now it becomes null, right? And it is as it is, but you can't compare null with it, right? It directly, we can see that it is directly not matching and we need to return 0 here. So that's why I'm returning 0 here. Else, what option we are having is S and EA. Then I need to check. Then when I check, then one of them becomes 0 again, the way it was here. So I need to turn 0 here, and the other case also, here S is there and E is there as I have removed A from this, but then when we go ahead, then either of them are again removed, right? So in this context, we'll again returning the 0 from this whole, we are only getting the 0. So this is the thing which we get from this particular sub portion of our string. Now let us check for the other side of the string, that how we are required to go ahead. So in other side, S, E and EA, now we'll remove E and A. So we'll take one by one by removing either of them in either of these portions. So first we removed E, so we got to this particular portion, and this is the same as this one, right? So everything would be that only, and it will again return 0. So here, now for next portion, we are removing A. So now it becomes S, E and E, right? Now we got the gas which are matching, right? So in this context, what we'll do, we'll remove both of them. So we have removed E from both. So now it becomes S and blank. So it will return 0. But as the string was matching and we have removed both of them, so we will be returning 1 from that perspective. So in that context, now we will return 1 from this side, and then this whole portion will return 1, and this whole portion will return 1 to this particular portion. And this whole would be returning 1 here. Now let us see for the another portion of the C and EA. Now here A matches at the first portion only, and we will remove both of the characters A from the both of string. Thus we'll add 1, and then we are having S, E and A. Now again E matches, so again we'll remove that E, and for that we'll add 1. But now it becomes blank in S, so that's why we'll return 0 here. But this 1 would also be returned. So combining both of these will return 1, and then again combining both of these will again, this will return 1, but combining both of them will return 2. So at the end, from this particular portion we are returning 2, and this particular portion we are returning 1. So it will now get to the parent caller, and we'll get the maximum out of 1 and 2. So our answer would be 2 here. So this is all how the recursive tree would work for this scenario. But one more thing is there, that we can see that these are the portions which are always repeating, right? And moreover, the space complexity, even the time complexity for this recursive solution would be something like this, because there is the possibility that both of the sides, there are 2 options, and for each option there could be possibility of m plus n. So it would be somehow exponential in order, and moreover space complexity would be as per the height of this. So number of cases which are being generated, so according to that only there would be the space complexity. So at max, because into m could be, that would be the space complexity, because at max the stack would be having, means at the worst case scenario, stack could have or the possible combination of n into m. So that would be the space complexity for this particular solution. So now the thing is that as there are generated subcases, right, which are common, so we can memoize these. This only is a thing which gives us hint of memoization. So now we are required to memoize the solution, and for memoizing we need to check that what are the things which are being essential in this particular question. Here the recurrence relation would be something like this. The recurrence relation would be so for a particular function which is there, then we are required to check, because we are deleting from the last, right? So we are basically doing n minus 1 in that scenario when they are equal. Else what we are doing is we are getting just maximum out of this, that is function of m minus 1 comma n or function of m comma n minus 1. So this is a recurrence relation which we are following here, and the base case would be when it directly reaches, means when either of them becomes 0, that is, this is the base case. So here the base case is some directly this, when n equals to 0 or m equals to 0, then we are returning 0. So this is our base case, this is our recurrence relation. So these are the two essential things which we are required for making our recursive code. Now comes the next part, as both of them are repeating in nature, various subcases are repeating, so we are required to memoize. Then how we can memoize this? We need to have a 2D vector, basically a 2D data structure which we are required, and that is, one is for the word 1 and one is for the word 2. So basically we'll use that 2D data structure and memoize on these recurrence relations only. Basically we'll fill up for the answer of these two functions in that memoize in that particular 2D vector, and this is how we can memoize this particular solution. So I'll show you all that in the code itself. Presently I'm just explaining. Now comes the next part, that memoization. After that memoization, as memoization was possible, so yeah, there could be possibility of iterative DP also. So in that iterative DP, earlier what we were doing was, we were directly going ahead in checking from the last, and we were checking that if match or not, then according to that only we were moving ahead. Here also we are required to do in that manner only. We are required to check that if both words are matching or not. If they are matching, then we are required to add one and subtract both of them, like that only. But here we would be making our DP table, and we will be checking from the starting itself that at this particular moment we'll check that for the previous rows and columns was if what was the answer which has been stored there, means what was the maximum answers till now which have been stored in the case of when they are equal and even when they are not equal. So this is the thing which we are doing in this particular iterative DP solution. When they are equal, then it's alright that yeah, they are equal, so we'll directly check the diagonal element and then we'll add 1 to it. But when they are not equal, then we'll check either from the side of word 1 or from the side of word 2, which one of them is maximum. This is the thing which we will be checking, and this is how our iterative DP will work. So here the time complexity would be same as Memoize solution only, that is n into m, and the space complexity would be again same as Memoize solution only, n into m. Here basically this is a state, and these two are at transitions, and this whole will make our iterative DP solution. But now the thing is that we can check from this particular transition solution only, and even from this one that we are just required for one previous column and one previous row only, right? So because of this, we can reduce our space complexity. So the thing is, for that context, where I've just written that what I observed, I'll show you in the code, that we are just required to check for the common char from previous one row, previous one column. That was the thing which we were doing in that table. And thus we can update by taking in size 2 vectors, and because of this only we can take 2 vectors and keep updating both of the vectors time and again, and that's how we can optimize the solution. So this was the whole explanation, and now let me walk you through the code that will make more clear. So let us first check for our recursive approach. Okay. So here what we are doing is this is that particular formula only, that combined size and then subtracting 2 into whatsoever LCS we'll be getting, that we are subtracting from this, and that would be our answer. So how we are doing LCS, it is that standard only. So if this is that base case and this is when both of them are equal, then we are just required to add 1 and remove both of the chars, and if they are not equal, then we are required to check for the maximum out of both of them while removing either from word 2 or from word 1. This is how we are going to do and go ahead with the recursive solution. Now comes the part for our memoise solution, because as we had seen that there are some things which are repeating also, right? So in that context, we can reduce the time complexity in space, not a time complexity also, but and space complexity for the same. Okay, space complexity is not reduced, it is basically increased, because earlier it was maximum of m into n. But no issues, we are more concerned with the time complexity. Means if there is a solution with better time complexity, then we'll go ahead with that, and we can compromise in that context with space complexity. So that's why we are memoizing here. So let us go ahead that how we can memoize that recursive solution. So first we are required with 2D vector, and the 2D vector we are doing this, means our vector size would be 1 plus word 1 size, and the columns count would be word 2 size plus 1, and we'll initialize all the rows and columns with -1. This is which we will be doing. Why we are initializing with -1? So that we could use that conditions here. And why we are adding 1? Because we require 1 row and 1 column for the fact to check what are there at the previous rows and column. So in that context, we are required with 1 extra row and column. Again, the same we were using for recursion. Now everything would be same as it was in recursion, only this condition is new, which is added so that we could use the DP of m and n, which we have introduced in this solution. This is again the same. We are just, when either of them is equal to 0, then we are assigning 0 to that particular position, and then if m minus 1 and n minus 1, basically either of those strings, if they are equal, then we are directly adding 1 and returning by deleting both the chars. This is what we would be doing, and here again doing the same thing only, but assigning it to DP vector. Okay, so now let's move ahead with our iterative solution. Here how we are doing is again taking 2D vector, same as we were doing in memoise solution. Now here we are taking 2 loops. Earlier we were not taking 2 loops, we were just having a recursive solution in such sense that it was taking for both of the words one by one, but it was required to check in consideration with other words, then only it could compare. So in that sense, it was becoming an end-to-end solution. So we could clearly see that they are nested, so it is an end-to-end solution. Now again, the condition is same only. When I equal to 0 or j equal to 0, then we need to continue, because the thing is that we have earlier only initialized each and every row with 0. So that's why dp of 0, 0 is already 0. So we need to just continue and go ahead. And then if both of them are equal, then again we need to assign the way we were doing previously. Else we need to check for maximum out of both. And at the end, the same formula which we are using till now, we need, but only thing is that earlier we were having a function call, but here we are not going ahead with that function call, but we are going ahead with the dp vector, which we have taken. And the last row and column, basically the last block of the dp, would be storing our answer. So that's why we are doing 2 times that last row and column, and then we are subtracting that from the combined lengths of the word 1 and word 2. So this is about iterative dp solution. Now comes the part for a space optimized solution. So for the space optimized solution, the thing is, we are taking this, but this is a mandatory condition, else we'll get the runtime error, because we would be just checking over our smallest length word. So that's why we are swapping here, and we are just taking n as the length of that word which is smallest, right? And also swapping the words accordingly because lengths have been swapped. Now, this is the biggest one. So the thing would be that we are just required to compare the chars of the bigger word, right, with the char of the smaller word. But we would be iterating in most of the sense with the smaller word. See, the thing is, when the outer loop is having, then outer loop somehow runs from 1 to 10, and then inner loop runs from 1 to 5, right? So whatsoever characters are there, we are easily able to check with the characters of the second one. But if it goes ahead in opposite direction, then there is possibility of runtime error in the same. So that's why we are checking in that scenario. Runtime error in these particular conditions would occur. Now comes the next part, the main conditions which are there. The C1 equals to word 2 of j, basically when they are equal. Then again, here what we are required to do is, earlier we were having it I and j, both of them. We were subtracting I minus I1 from both of the I and j, right? But now we are going ahead with that j plus 1. Basically it is the same the way we were doing it. Earlier we were using j and then we were equating it with j minus 1. But now here what we are doing is, here we are just going ahead with j plus 1, and then whatever was stored at the last, basically we are taking that 2 vectors also, right? These dp last and dp current. So this dp last, whatsoever was being stored in that, will directly add 1 to it and store in our dp current. This is in that scenario when both of them are equal. When both of them are not equal, then in that scenario what we would be going ahead is that we will take for our present vector, that is this dp current, and with the present word which we are having, and we will take for the dp last vector, in which we will take for the next one which is there, and we'll compare both of them, and then we'll directly add compare both of them, whosoever is maximum out of them, then we'll directly assign that to dp current of j plus 1. So this is somehow, not somehow, but this is similar to that only, which we were doing earlier in this sense, and we were having the answer here. So this dp current j, it is basically storing everything which we are having in this present, and this dp last j plus 1, it is storing everything which we are having here. So that's why we are able to figure out that which is the out of them which one would be the maximum, and we'll assign that to dp current of j plus 1. Then this is the mandatory step to swap both of them, so that now we could see there would be rows like this, right? And if we are at this particular row and this particular row, this is our current row and this is our last row, then when we swap both of them, then our whatever answer we were having, so now last would become directly as this, right? But that dp current will be having everything which we are having in this last. So both of them would be swapped. So, but now, right, because we are more concerned about this particular last only. But this current, even if it is swapped with the values of last, but we are already assigning new values to this dp of current only, right? So that's why it will be again updated with this particular loop itself. Now at the end, after all this, at the end we are required to return answer from that formula itself. Everything would be stored in the last of that dp last vector, and then we are directly multiplying with 2, the way we were doing with all the previous solutions, and this will give us the answer. So these are all for this particular question, basically just the variation of that else here. So this was all. If you have any doubt, you could comment that down. So yeah, thank you.